Good morning, students. This is Math 2008, and today is June 12th. We're recording our first session today. What are we going to do today? Somebody asked me to do a particular problem from section 1, chapter 1. That's 1.1. I will do that. And then we'll give you a lecture on 1.2. By the end of the day, you should be able to do the problems I assigned from 1.2. And if you go here, you'll be able to see they have been assigned. Go to My MATLAB homework. And 1.1 has been assigned. 1.2 has been just assigned. Okay? So by the end of today, you should be able to do all the problems from 1.2. In case you can't, you can always ask me to do some of those problems. All right, well, let's start our lesson. So somebody asked me to do this problem, part C, 8 plus 17 plus 26 plus 35, all the way up to 890. Find the sum of this using Gauss's method. So I'm going to work on this problem. And just to let you know, the one I originally did had error, and somebody was nice enough to point it out. So thanks to that person, and it's much appreciated. I'll try to be careful next time. Okay? All right. So I'm just going to take this 8 plus 17 plus 26 plus 35 plus dot dot dot. Okay. Since I need room, I'm going to get rid of this. Now, I need to find the position of the last term, 890. I'm going to call it A subscript N. A subscript N. That's the last term. I'm going to put it here. And the first term is clearly 8. I'm going to put it here. All right, now A subscript N, I have a formula, is equal to A subscript 1 plus D times N minus 1. Now, the first term is, excuse me, the first term is 8. And the common difference is, the first term is 8, and the common difference is 9, because 17 minus 8 is 9, 26 minus 17 is 9, 35 minus 26 is 9, so I'm going to put 9 here. Now, I am looking for N, and A subscript N is, as shown above, 890. Okay, I'm going to do some work here. 8 plus 9N minus 9. Now, I can work on the right-hand side further, and this is what I get. This can be written as 9N minus 1, because 8 minus 9 is minus 1. I'm going to add 1 to both sides, and this is what I'm going to get. 890 plus 1 is equal to this. And this means 891 divided by 9. I'm going to divide both sides by 9. Let's see what we get from that. Okay, I'm going to put it here. Hopefully you can follow. Now I'm going to use my calculator. 891 divided by 9. Okay, so let's work on it. 891 891 divided by 9, I'm getting 99. So this means this is 99. Now, that's correct. I was off last time, okay? Now, I'm going to delete all this. Nth term is, N is 99, 890 is the 99th term. So now I can say, so again, this is hopefully being recorded, so I'm going to delete all that. I'm going to write here, this is 99, a subscript 99. Now I'm going to use Gauss. Now I need more room, so I'm going to delete all this. So what I have here, um, I know the term 890 is the 90th, 99th term, not 98. So I'm going to write the whole thing in reverse order as follows. And each time I'm going to get 898. And that helps a lot. I know on line 3, I will have 898. How many times? 99 times. 898, 99 times. What does that turn out to be? I do need my calculator. Let's grab it. So I need to find 898 times 99. 898 times 99. Now I'm getting this number, 88,902. Now this first line can't be that. It has to be that number divided by 2. And I'm going to use my calculator as usual. I'm getting this number, 44,451. That's the answer. And Amy caught my mistake and took the trouble to solve the problem correctly. Thank you, Amy. So that's the right answer. Okay, guys, sorry about that. Okay, let's write it down here somewhere. Okay, arithmetic sequence was going up by a fixed number. Okay, 2, 4, excuse me, 2, 4, 6, 8, it's going up by 2. Geometric sequence looks like this. I'm going to give you an example, then I'm going to explain it to you. Okay, what's going on? What do you see? Do you see any patterns? Well, it seems like they're taking the first number, multiplying it by 3, taking the second number, multiplying it by 3, taking the third number, multiplying it by 3. And 30, yeah, that's about right. So similarly, like we did earlier, first term is still A1, A1. The second term is A2, A3, A4, so on and so forth. I'm not going to write all those terms, okay? Now, whatever you multiply by is called common ratio. I'm going to write it down. The common ratio is, for this problem, common ratio is 3. So you multiply the first term by 3 to get the second term by 3 to get the third term by 3 to get the fourth term, so on and so forth. We use R to denote common ratio. Okay, we say R is 3, not D. D is common difference. We say R is 3. Let's put an equal sign here. Now, now, we are going to find, suppose the nth term. How do we find the nth term? How do we find the fifth term? So let's do some work here. So what do we see? We're going to take this example. All right, guys. A1 is easy. It has to be given. The first term, you have to know the first term is 2. All right. The second term is 2, which is the first term, times the common ratio, which is 3. Okay. The third term is the common ratio. The first term multiplied by the common ratio gives you the second term. You take the second term multiplied further by 3. So we're going to write it like this. We're going to write it power 2. Take a look. How do you get 18? 3 times 3 is 9. 9 times 2 is 18. How do you find the fourth term? Not too difficult. The fourth term, I'm going to write here because I need the room, is 2 times 3. So do you see what's going on? To find the fourth term, you take the first term and then take the common ratio to the power 3, okay? Not 4. It's consistent. When this is 3, this is 2. When this is 2, you can pretend there's a little 1, okay? So we are going to give you guys one more formula that you want to know. So for instance, I am gonna, let me get rid of this. I give you the same geometric sequence and ask you to find the 100th term. Well, the 100th term, take this. We're gonna write the formula that you wanna know. A subscript n is equal to A subscript 1 times R raised to the power. Okay, there's not enough. No, it should be in -1. Okay, for a geometric sequence, this formula, let's highlight it a little bit. This formula is very, very important. The nth term is the first term times common ratio raised to the power n minus 1. If you check here, it's consistent 3, 2, 2, 1, 4, 3. So if somebody gives you a geometric sequence and wants you to find the sixth term, seventh term, you should be able to use that formula in the pink box to find it. That's kind of all you need to know about geometric sequence and to do the problems I have assigned from 1.2. Well, that's one part of our 1.2. Let's move on to the second part. The second part is we're going to talk about square numbers. What are square numbers? Let's write it down. Square numbers. Well, they're actually fairly simple. First square number is 1 squared. The second square number is 2 squared. So let's write it down properly. 1 squared. The second squared number is 2 squared. The third one is 3 squared. Dot, dot, dot. Now, these numbers are what, really, guys? So they won't do it so nicely for you, right? They're going to say 1. Here's the kind of pattern they'll give you. 4. 3 squared is 9. So if you see something like this, 1, 4, 9, they want you to find the next number. You have to notice that the first one is 1 squared, the second one is 2 squared, the third one is 3 squared. So if they want you to find the next term, you would say, well, that's easy, 4 squared. Let's do it right here, which is 16. And if they want you to find the 100th square number, 100, easy. You're going to say, this is, we still write it like this, 100 square number. We say find this. If we are talking about square numbers, you're going to simply do this. Done. 100 square number. Okay, guys, so far we have talked about the geometric sequence. We have talked about square numbers. We have something else called triangular numbers now. For that, I have to go to my notes. It's in your book. It's in your book, and my notes are really the same. But let me access it. All right. So we talked about square numbers. Okay. Triangular numbers are actually something we have already talked about. They're connected to, excuse me, Gauss's sum. So the first triangular number is T1, which is 1 dot. The second triangular number is 1 and 2. The third triangular number is 1 plus 2 plus 3. The fourth triangular number is 1 plus 2 plus 3 plus 4. And we know how to find Gauss's sum. So if I want you to find the 100th triangular number, you would say 1 plus 2 plus 3 plus 4, all the way up to 100. So let's find the 100th triangular number. Again, this is something you want to understand, how triangular numbers are defined. When you arrange them as if they're dots, you should be able to form a triangle. T1 is 1, T2 is 1 plus 2 or 3, T3 is 1 plus 2 plus 3 or 6, T4 is 1 plus 2 plus 3 plus 4 or 10. So we're going to kind of review Gauss again, not a problem. And this is, I call it the simple Gauss. I want you to find, suppose, T100, T100. You can just tell me, oh, that's easy. That's not going to cut it. Okay. You have to find this sum, 1 plus 2 plus 3, all the way up to 100, which is very easy to do, right? We have done it. I'll do it again. You're going to take this line and write it in two different formats. And then you're going to add it. Okay, each time it's going to be 101. Each time it's going to be 101. 100 plus 1 is 101. I'm going to put a bunch of dots here. I don't, it's the same. All right. Now, on the third line, I know my font changed, guys. I don't have any control over it, but it looks a little bigger. I will still have 100 terms. 1 times 100, and that turns out to be 101, double zero. Now, my final answer for this one is going to be this number, 101, 100 divided by 2. Why do I divide it by 2? Because the third line has the same original question twice. And I'm going to go back to my calculator. I think I know the answer, but I still want to check. Already made a tiny error here. Let's fix it. I am getting 5,050. So the 100 triangular number is simply 1 plus 2 plus 3 all the way up to 100, but you have to use Gauss's method to calculate the final answer, and it turns out to be 5,050. This is my answer. And on the exam, that's all I expect you to write. Okay, guys? So these are the topics you really need to know to answer some of the questions I asked on MATLAB. I'm going to go over a couple of problems from your book, um, examples that your book did. Um, those problems will also come in handy because the ones I have assigned are similar to those. So let's go ahead and do a couple of examples from your book. All right, let's see. First problem I want to do is this problem. Of course, it's a pattern related problem. Okay, it's one of the examples from your book from 1.2. I don't remember the page number and don't want to waste your time and go there. Let's read the question. Find a numerical pattern in the number of matchsticks required to continue the sequence shown in figure 11 if each subsequent sequence has one more square. So what kind of pattern is this? Well, they're talking about the number of matchsticks. That's important, okay? Why is that important? Well, you could be talking about the number of squares. They're not talking about the number of squares. They're talking about the number of matchsticks. Well, the first one, um, I'm gonna write it like this, okay? I'm gonna write it like this. The first one has how many matchsticks? That has 4 matchsticks. The second one has how many matchsticks? If you count it carefully, it's not 8. I know there are 2 squares, but it's actually 7. And the third one has how many matchsticks? It's actually 10. If you count the matchsticks, you're going to get 10. The fourth one has how many matchsticks? Well, if you carefully count, it's going to be 13. Now you look at the numbers. Now you look at the numbers and you say, well, uh, this is an arithmetic sequence, clearly, because it's going up by 3 consistently. And its common difference is 3. It's going up by 3, and the first term is 4. Now, when I give you a problem like this, and when you do the problems on MATLAB, you're going to see they'll ask you to find the 100th position. How many matchsticks will be needed for the 100th term? Very easy to do. You'll do something like this. A subscript 100 is going to be first term plus d times the common difference. Sorry, d is the common difference times n minus 1. Well, let's write down our original formula that we really need to know. Now, the question says find the 100th term. Find the 100th term. Let's add it. Find the 100th term. Let's say I added this part to the problem. All right. So you have this formula. All you have to do is replace n with 100 throughout, and that's what you're looking for. And A1 is the first term, which turns out to be 4. D is the common difference, which is 3, and is 100 again. Okay? Make it a little smaller. I need the room. Now, almost done. I have to simplify the right-hand side of this last equation. 100 minus 1 is 99. I'm going to write it. 99 times 3 is what? Of course, you can use your, well, I'm just going to use my calculator. I don't want to make a mistake. I don't know how to do it in my head, but 99 times 3 is 297. And 297 plus 4 is 301. So the 100th term is 301. So here's an example from your book. This should help you with the problems I have assigned. And I will do one more problem from your book. Okay? It's also an example. Now, don't panic. Looks like a difficult problem, but it's not. Okay, let's read the question very carefully. The diagrams in figure 12 show the molecular structure of alkanes, the class of hydrocarbons. C represents a carbon and H a hydrogen connecting in this way. So I think they'll tell you, I don't have it, let's make up a problem. I'll tell you how many hydrogen atoms, let's write it down. So this is the main question or a structure that's in your book, okay? The questions I would ask or I could ask is if C is 7, find H, number of H. Okay, I know it looks like a chemistry problem, but it's really not. Let me put it down. I'm going to do this a little differently, okay? So there are 7 carbon atoms. Find, if this is 1, find the number of H, number of hydrogen atoms needed to make the compound. Okay? So if C is 7, find the number of H, which is hydrogen atoms needed to make the compound. Well, take a look at the structure, guys. C, whatever C is, you're going to get 1 on the top, 1 in the bottom. Now, note, I'm going to do it visually, okay? They're going to be there, okay? Every atom has 2 here. Don't worry about them, all right? No matter how large or how small the compound is, these 2 endpoints will be there. But for all the ones in the middle, for every C, you have 2H. For every C, you have 2H. So this is how I'm going to do this problem. I'm going to say the answer is what? The answer is going to be my 2 at the 2 endpoints. Leave it there. And then however many C you have, we have 7 Cs. You're going to multiply that by 2. And that's it. Sorry, somebody's emailing me. This is going to be 16. Now, you don't have to draw it. Okay, I'm going to go over it once again. So the question says, here's the structure. If you have a structure with 7 Cs, all right, 7 Cs, how many H or hydrogen atoms would you need? Well, these 2 guys are going to be always there. So that's why we have the 2. Then for each C, I will get 2H. Each C, 2H. So you take the number of C given in your question, multiply it by 2, and you have 16. Because 7 times 2 is 14. 14 plus 2 is 16. Now you might say, oh, I'm just going to draw it. Well, what if I give you, what if I make this 100? You won't have time to draw it. How would that change this answer? Well, easy. Just replace it with 100, and this is going to be 202. So let me put it here. Once again, I have this 2 for the 2 endpoints. It doesn't matter how long your carbon chain is, you'll always have 2, exactly 2. There are 100 Cs, 100 Cs. Every C has 1 on top, 1 on the bottom. That's where this 2 is coming from. 2 times 100 is 200. 200 plus 2 is 202. So I hope that helps. You should be able to do all the problems I assigned from 1.2. Just to let you know, guys, I'm teaching three courses. If I mess up the section, my apologies in advance. I'll try not to. We're doing 1.2. We wrapped up 1.2. I think you should be able to finish 1.2. Good luck. If you can do a couple of problems, give me a clear screenshot and tell me your course number. I'm teaching three courses, so always mention your course number and give me a screenshot of the problem you can do. I'll be happy to do it. I'll see you next class. Hopefully, I'll record another video next class. Thank you, guys.